Everyone, my name is Nikita. I am from EC branch. My subject is Digital System and Design, and my topic is JK Flip Flop. What is JK Flip Flop? JK Flip Flop is one of the most used flip flops in digital circuit. The universal flip flop has two inputs, J and K. The JK flip flop is gated SR flip flop of or SR flip flop with a clock input cir- circuitry that prevents the illegal or invalid output when both inputs S and R equal to logic level 1. In the SR flip flop, the S and R are shortened letters for the set and reset, but J and K are not. Instead, the J and K are autonomous letters chosen to distinguish the flip flop design from other types. Let us discuss in details JK flip flop in the upcoming section. The JK flip flop is one of the most used flip flop in digital circuit. The JK flip flop is a universal flip flop having two inputs J and K. In SR flip flop, the S and R are shortened letters for set and reset, but JK are not. The JK are themselves autonomous letters which are chosen to distinguish the flip flop design from other types. Unlike the JK flip flop, the basic SR NAND flip flop circuit has many advantages and uses in sequential logic circuit, but it suffers from two basic switching problems. First one is the set is equals to 0 and reset is equals to 0. Second one is the set or reset changes states. Then to overcome these two fundamental design problems with the SR flip flop design, the JK flip flop was developed. This simple JK flip flop is the most widely used of all flip flops designs and is considered to be a universal flip flop circuit. The two inputs labeled J and K are not shortened letters of words such as S for set and R is reset, but are themselves autonomous letters chosen by its inventor Jack Kilby to distinguish the flip flop design from other types. The sequential operation of the JK flip flop is exactly the same as for the previous SR flip flop with the same set and reset inputs. The different these time is that the JK flip flop has no invalid or forbidden input states of the SR latch even S and R are both at logic 1. The JK flip flop is basically is gated SR flip flop with the addition of a clock input circuitry that prevents the illegal or invalid output condition that can occur when both input S and R are equal to the logic level 1. Due to this additional clocked input, a JK flip flop has four possible input combination: logic 1, logic 0 or no change and toggle. The symbol for a JK flip flop is similar to that of an SR bistable latch as seen in the previous figure. Both S and R are inputs of the previous S and SR bistable have now been replaced by two inputs called the J and K inputs, respectively after its inventor Jack Kilby. Then these equates to J is equals to S and K is equals to R. The two inputs AND gate of the gated SR have now been replaced by three inputs, three NAND inputs with the third input of each gate connected to the outputs at Q is equals to Q bar. This cross coupling of the SR flip flop allows the previously invalid condition of S is equals to 1 and R is equals to 1 state to be used to produce a toggle action as the two inputs are now interlocked. If the circuit is now set, the J input is inhibited by the zero states of Q bar through the lower NAND gate. If the circuit is reset, the K input is inhibited by the zero status of Q through the upper NAND gate as Q and Q bar are always different we can use them to control the input. When both inputs J and K are equal to logic 1, then JK flip-flop toggle has shown figure in the truth table. JK flip-flop circuit diagram. The logic diagram of JK flip-flop with data input J and K end with Q0 and Q respectively. And to obtain S and R inputs, that is JK flip-flop full form. JK flip-flop full form is Jackie Kilby flip-flop. It is named after its inventor Jackie Philp. They invented the integrated circuit in 1958. JK flip-flop truth table. The JK flip-flop truth table has the hold state, reset state, set state, and toggle state. As this is a refinement of SR flip-flop, the truth table of SR flip-flop is refined to make the truth table of JK flip-flop. The truth table of JK flip-flop has two inputs, J and K. Qn denoted the current state and Qn plus 1 denotes the next state of the table given below. Here we can see the table. If Here we can say hold, reset, set, and toggle. Excitation table for JK flip-flop. The excitation table of the JK flip-flop has the current state denoted by Qn and the next state is denoted by Qn plus 1. It has the J and K inputs for each transition in the excitation table of the JK flip-flop are as follow. Here Qn and Qn plus 1 are the inputs, J and K are the outputs. Case A. When Qn is equals to 0 and Qn plus 1 is equals to 0, this condition can happen with either J is equals to 0 and K is equals to 0 or J is equals to 0 and K is equals to 1. Characteristic table. Therefore, the desired output Qn plus 1 is equals to 0 is obtained when J is equals to 0 and K is equals to X. Case B. When Qn is equals to 0 and Qn plus 1 is equals to 1, these can happen with either J is equals to 1 and K is equals to 0 or J is equals to 1 and K is equals to 1. It is a toggle condition, which means in the toggle mode, a JK flip-flop has J is equals to 1 and K is equals to 1. Therefore, the desired output Qn plus 1 is equals to 1 is obtained when J is equals to 1 and K is equals to X is don't care. Case C. When Qn is equals to 1 and Qn plus 1 is equals to 0, these can happen with either J is equals to 0 and K is equals to 1 or J is equals to 1 and K is equals to 0. Therefore, the desired output Qn plus 1 is equals to 0. If any input is 0, then output is 0. E is obtained when J is equals to X is don't care and K is equals to 1. Case D. When Qn is equals to 1 and Qn plus 1 is equals to 1, these condition can happen with either J is equals to 0 or K is equals to 0 or J is equals to 1 and K is equals to 0. Thus, the desired output Qn plus 1 is equals to 1 is obtained with J is equals to X and K is equals to 0. Then the flip-flop is obtained on SR flip-flop is feedback when which enables only one of its two input terminals, either set or reset, to be active at any one time under normal switching, thereby eliminating the invalid condition seen previously in the SR flip-flop circuit. However, if both the JK inputs are high at logic 1, when the clock input goes high, the circuit will toggle as its input switch and changes state complementing each other. These results in the JK flip-flop, acting more like a T-type toggle flip-flop when both terminals are high. However, as the outputs are feedback to the input, this can cause the output at Q to oscillate between set and reset continuously after being complemented once. While these JK flip-flop circuit is improvement on the clock SR flip-flop, it is also suffers from timing problem called race. If the output Q changes states before the timing pulse of the clock input has time to off to avoid these, the timing pulse period T must be kept as short as possible. as this is sometimes not possible with the basic JKs built using basic NAND or NOT gates. Far more advanced master slave flip flops were developed which are more stable. Characteristic table. The characteristic table of the JK flip flop has the hold state, reset state, set state, and toggle state. The characteristic table has the input J and output K. Qn and Qn plus 1 denotes the current state, denotes the next state in the characteristic table given below. Here J and K are the inputs, Qn and Qn plus 1 are the outputs, and this is the state which holds the setter state or reset state and toggle state. Characteristic table. Characteristic equation. The characteristic equation of the JK flip flop from the above characteristic table has the hold state, reset state, set state, and toggle state. Using the three variable K map. In the K map, the column K and Qn is common and JQ is common. So the characteristic equation is Qn plus 1 is equals to JQn bar plus K bar Qn. JK flip flop waveform. Here we can see the JK flip flop waveform. Master slave JK flip flop. Master slave JK flip flop eliminates all the timing problems by using two SR flip flops connected together in series configuration. One flip flop acts as a master circuit which triggers on a leading edge of the clock pulse, while the other acts as a slave circuit which triggers as a falling edge of the clock pulse. This results is a two section, the master section and the slave section being enabled during opposite half cycle of the clock signal. In the dual JK flip flop IC, which contains two individual JK type within a single chip enabling single or master slave toggle flip flops to be made. Others such as IC includes the dual JK flip flop with clear. The master slave flip flop is basically two gated SR flip flop connected together in series configuration with the slave having an inverted clock pulse. The output from Q and Q bar from the slave flip flops are feedback to the inputs of these masters with the output of the master flip flop being connected to inputs of the slave flip flop. This feedback configuration from the slave's output of the master's input gives the characteristic toggle as shown in figure. The input signal J and K are connected to the gate's master's SR flip flop which looks the input condition while the clock CLK input is high at logic level 1. As the clock input of the slave flip flop is inverse of the master clock input, the slave SR flip flop does not toggle. The output from the master flip flop are only seen by the gated slave flip flop when the clock input goes low to logic level 0. And master slave flip flop is constructed from two flip flops, a master and a slave flip flop, and an inverter. On the rising edge of CLK, that is positive edge, the control input are used to determine the output of the masters. When the CLK goes low, the state of master is transferred to the slave whose outputs are Q and Q bar. In the master slave flip flop, the output is entirely dependent upon the output of the slave's flip flop. When the clock is low, the output from the master slave flip flop are latched and any additional changes to the inputs are ignored. The gate slave's flip flop now respond to the state of its input passed over by the master section. Then the low to high transition of the clock pulse, the input of the master flip flop are feed through to the gated inputs of the slave flip flop. And on high to low transition, the same inputs are reflected on the output of the slave making these type of flip flop edges or pulse triggered. Then the circuit accepts input data when the clock signal is high and passes the data to the output of the falling edge of the clock signal. In other words, the master slave flip flop is a synchronous device as it only passes data with the timing of the clock signal. Here is a logic diagram for master slave flip flop. When the clock pulse CLK is 0, the output of the inverter is 1. Since the clock input of the slave is 1, the flip flop is enabled and output Q is equal to Y. While 0 is equal to 7, the master flip flop is disabled because CLK is equal to 0. When the pulse becomes 1, the information at the external R and S inputs is transmitted to the master flip flop. In the slave flip flop, the clock is 0 because the inverter output to 0, that is, a slave flip flop is isolated. When the pulse returned to the master flip flop is isolated, preventing external input from affecting it. The slave flip flop then goes to the same state as a master flip flop. Master flip flop using NAND gate. Thank you.